Okay, welcome to my presentation of District Mathematics, Kathmandu University School of Education, QSOT, Department of STEM Education Mathematics, Hattiban Lallipur, Nepal. PowerPoint presentations prepared by Gaurav Thapa, MA Mathematics, first semester 2023, 7 January 2023. Course facilitator, Mr. Nithar Kumar Manandar, District Mathematics. Today I got a topic of conditional and biconditional statements, in which we are going to discuss about various things in it. First of all, let's discuss what is meant by conditional statement. A conditional statement is of the form if P then Q, and this is written as P implies Q. A biconditional statement is of the form P if and only if Q, and this is written as P double implies Q. And next we have a statement or proposition is a sentence that is true or false, but not both. A compound statement are formed from simple statements by using the connective words such as it may be or, and, if, then, if and only if, and so on. The individual statements are represented as P and Q, and the compound statements are represented by one of the P or Q, P and Q, P imply Q, and we have the next term, negation. If P is a statement variable, the negation of P is not P, or it is not the case that P. And also, it is denoted P, it has opposite truth value from P. If P is true, then Q is false. If P is false, then Q is true, and that is the vice versa. That is opposite in, they are opposite in meaning. For example, if one is tall, then next will be short. Now next, conjunction. It comes under the same topic. A word used to connect clause or sentence, or to coordinate words in the same clause. So, example, and, but, if. This we use in English grammar as well. If P and Q are the statement variables, the conjunction of P and Q is P and Q, denoted as P and Q symbol. It is true when and only when both P and Q are true. If either P or Q is false, or if both P are false, P and Q is false. Now disjunction. If P and Q are statement variables, the disjunction of P and Q is P or Q, denoted P or Q. It is true when either P is true or Q is true, or both P and Q are true. It is false only when both P and Q are false. Now, logical equivalence. Let us discuss what is meant by, first of all, logical equivalence. Two statements forms are called logically equivalent if and only if they have identical truth values for each possible substitution of statements for their statement variables. The logical equivalence of statements forms P and Q is denoted by writing P plus Q. Two statements are logically equivalent if and only if they have logically equivalent forms when identical component statements variables are used to replace identical component statement. Now we have the next topic, tautology and contradictions. A tautology is a statement that is always true regardless of true values of the individual statements substituted for its statement variables. A statement whose form is a tautology and is a tautology statement. A contradiction is a statement form that is always false regardless of the truth values of the individual statement substituted for its statement variables. Or a statement whose form is contradiction is a contradictory statement. Now let's discuss about logical equivalence in detail. One example, the statement 6 is greater than 2 and 2 is less than 6 are two different ways of saying the same things. Why? Because of the definition of phrases greater than or less than. By contrast, although the statements others are also different ways of saying the same thing. The reason has nothing to do with the definition of the words, it has to do with the logical form of the statement. Any two statements or logical forms are related in the same way as 1 and 2 would either be true or both be false. We can see this examine the following truth table, where the statement variables P and Q are substituted for the components statements dogs, bugs, and cow mews respectively. The table shows that for each of the combination of truth values for P and Q, similarly P and Q, right, is true, and when only when P or Q is true. In such case, the statement forms are called logical equivalents, and we say that 1 and 2 are logically equivalent relations. And next, tautologies and contradictions. Tautology is a statement that forms always true regardless of the truth values of the individual statements substituted for its statement variables. A statement whose form or tautology is tautological statement. Now next, contradiction. A contradiction is a statement that is always false regardless of the truth values of the individual statements substituted for its statement variables. A statement whose form is contradiction is a contradictory statement. Now some example: a conditional statement and its contrapositive, converse and inverse, which is related to conditional and biconditional statement. If x is divisible by 10, then it is divisible by 5. Similarly, it is p then q. Contrapositive not q implies not p. That is, if x is not divisible by 5, then it is not divisible by 10. Now converse, that is q implies p. If x is divisible by 5, then it is divisible by 10. Inverse, not p implies not q. That is, if x is not divisible by 5, then it is not divisible by 10. Now some examples of biconditional statement. The example of biconditional statement 1. The side of right angle triangle is hypotenuse if and only if it is longest side. Here to discuss either it is necessary or sufficient condition or both, we can go with the point as P is sufficient condition for Q and P and Q, so it matches with the above examples. Also, P is necessary condition for Q. If not P, then Q, not Q. The side of right angle triangle isn't hypotenuse if it is not the longest side, which satisfies the necessary condition too. P is necessary and sufficient condition for P is to Q if and only if Q. The side of right angle triangle is hypotenuse if and only if it is the longest side. It also holds both conditions, so the above example is biconditional statement which satisfies the necessary condition. Now let us talk some truth tables as we will meet in this topic. Truth table for conjunction. If P is true and Q is true, then P and Q is true. If P is true and Q is true, it is true. If P is true and Q is false, it is false. If P is false and Q is true, it is false. If P and Q both are false, then it is false. Now next, truth table for disjunction. Or if P and Q are true, it is true. If P is true and Q is false, it is true. If P is false and Q is true, it is true. And if both P and Q are false, then it is false. Okay, thank you.